Okay, so this lecture is going to be Unit 3. One thing that I would recommend is if you're watching this, please feel free to start and stop the lecture as needed. If I go too fast, feel free to stop it and rewind and rewatch that part. Also, make sure you're taking notes as you go through this lecture and write your problems down and how to work it. This is really for you to learn, not just for you to copy. Okay? Unit 3 is dealing with absolute value equations, square root property, and radical equations. So we're going to start off with absolute value equations. Our first concept that we need to understand is just what is an absolute value and what does that mean. So let's look at two examples. Let's say we have the absolute value of 2, and we're going to compare that to the absolute value of -2. Now, many of you may remember that the absolute value means that any number inside there is going to come out positive. And that is definitely the case here. The absolute value of 2 is 2, and the absolute value of -2 is also 2. One way we can think about that is on a number line. So if we have 0 in the middle and we're looking at 2 over here, then the distance from 0 is the absolute value. So absolute value is a distance, and we can see that that is 2 units, so that is why our answer is 2. But the same thing applies when we go in the negative direction. So if we're asking how far is it from 0, then we are 2 units away, and again, distance is always positive. So either one of these is going to give us an answer of 2. One thing you probably notice is that these two numbers are different on the inside, but it's producing the same number on the outside, or as the answer. And so that's something we have to take into consideration when we're dealing with absolute value equations. What we're going to do first is in any absolute value equation, like number 1, we need to get the absolute value by itself first. So in order to do that, we're going to subtract 1 from both sides. This is using those same linear equation rules that we used in Unit 1. This is going to give us the absolute value of x minus 2 equals 7 minus 1 is 6. Now, how do we take this into account where there's really two different numbers that can happen inside and generate the same answer? The easy way to do this is to consider that the number on the right-hand side can be plus or minus. So our next step is going to look like the inside of the absolute value with the absolute value bars taken off. So now we're kind of taking the absolute value here. And this is going to equal plus or minus 6. Now, mathematically, technically, there's a plus or minus kind of on the inside here. Don't write that. But mathematically, also, that plus or minus will translate to the right-hand side. So this is the easy way to think of it. From here, we want to take into account that we're getting two answers. So we're going to split this into two equations. The first equation is going to be x minus 2 equals the positive number, 6 in this case. The right equation is x minus 2 equals the negative number, negative 6 in this case. And this, we need to solve each one separately. On the left-hand side, we're going to add 2 to both sides. And that's going to give us x equals 8. And on the right-hand side, we do the same thing, add 2 to both sides, and that will give us x equals -4. Okay, so how would you write this in the computer when you're working your homework? This needs to be written as a list. So 8, comma, -4. Order does not matter, so you could write the -4 first if you wanted, and then the 8. And also, just as a note, you do not put parentheses around this because this is not an ordered pair. Okay, so absolute value problems generate two answers. That's one thing to remember. And we're going to add this little plus or minus after solving for the absolute value, however you want to write that. Let's do the same thing on the right-hand side. So if we're looking at the right-hand side, notice that in number 1, we had a number over here on the left with the absolute value. The absolute value was not by itself. But on number 2, we do have the absolute value by itself. So we can go straight to this step. That is removing the absolute value bars, 4x plus 1, equals, on the right-hand side, doing the plus minus 8. So we can just jump straight to that because we have nothing to move over. And then from there, we're going to separate this into 4x plus 1 equals 8, and 4x plus 1 equals negative 8. And then we're going to solve each one of those. So subtract 1 from each side to get 4x equals 7, and divide by 4. And that gives us x equals 7/4. Doing the same thing on the right-hand side, subtract 1 from both sides. That's 4x equals negative 9, and divide by 4 gives me x equals negative 9/4. And again, we're writing our answer as a list, so this would be 7/4, comma, negative 9/4. All right, let's look at number 3. So number 3, our absolute value is again not by itself. So we want to move the 12 over by subtracting first. That's going to give us the absolute value of x minus 3 equals negative 7. And right here, you notice that if you tried to do the next step, you would have x minus 3 equals, but normally that number on the right-hand side is positive, and we have a negative there. So we really can't put a plus minus, and that tells you that there's something special going on here. So we talked about what absolute value means at the beginning of this lecture, and that was the distance from 0, and I also said distance is never negative. So in this case, we have an absolute value set equal to a negative number, and that can never happen. You're never going to get a negative number out of that. So this answer happens to be no solution, and in the computer, you would write D and E. You're probably already familiar with that a little bit because we've done quite a few problems like that now. Moving over to number 4, you can see kind of end up the same way just from the get-go. So here we've got an absolute value set equal to a negative number, and that's going to go straight to D and E, or no solution. One of the reasons why I wanted to show you 3 and 4 in these two formats is because 3 can be really deceptive. If you look, our original numbers are positive with those two numbers. You don't really see the negative until you move it over. So that's why it's really important to move all the numbers away from the absolute value and get that absolute value by itself first before you make a decision on what to do next. So again, if it works out, if we end up with a positive number on the right-hand side, you do end up getting 2 answers. If it's set equal to a negative, you end up getting no solution, or D and E. So that's the end of our absolute value equations. Let's move on to complex numbers and taking square roots. Okay, number 5, we've got the square root of 4. And I know most of you are going to tell me, oh, it's 2. And that is true. You're exactly right. It is 2. What I want us to really think about is why is it 2? Because this helps us understand what to do in our next few problems. So why is this 2? There's a few ways to think about this. The first one is, obviously, 4 is broken down into 2 times 2. And because this is a square root, the square root generates a 2 right there in what's called the index. You probably know it from being like a cube root in the little 3 there. We don't normally write the 2 because it's understood for a square root. However, that helps us know how many identical numbers we need under that radical in order to bring one number outside that radical. So that's one way to think of it. If you've got a pair, one of those numbers, basically they kind of join together and just leave you with that 2. Another way to think about this is that if I rewrite 2 times 2, I get the square root of 2 squared. And this is a key concept that I want you all to learn in this unit. That is that if we have a square root and a square, those two things are inverse operations. So they're opposites of each other. And just like if we had a plus, we would do a minus. Here, these two things are going to cancel each other out. And that leaves us with the 2. So if we can find a pair of numbers that are identical, we can write it as that number squared, and that square root and that square will cancel. And that becomes really important, especially here in a little bit. So let's take that into consideration for number 6. Number 6, we've got square root of negative 9. Now that negative is a little tricky, so what I would suggest doing is separating that negative out and just having the square root of 9. And we're going to take that negative out and make it negative 1. Now, why am I doing negative 1? Because 9 times negative 1 is negative 9. So really, though, I have that negative hanging out there. It really is -1 hanging there. All right. How could I write the square root of 9? I could write it as 3 times 3, which is the same thing as 3 squared. How can I write the square root of -1? This is a new concept. So we can see right here, we have, that did not change, one moment. We have the square root of -1 is I. So that square root completely goes away. The negative completely goes away. The 1 clearly completely goes away. And I just end up with an I here. Okay, so now let's simplify this. The square root of 3 squared is just 3, and the I comes down. Now, a quick note about the calculator with these problems. You are not going to be able to put square root of -9 in the calculator. It is going to give you an error, and that is because it generates an I and your calculator is not set to understand that. However, you can put the square root of 9 in your calculator. Okay, so you could do that in your calculator, and then you just have to know the square root of -1 is I. All right, let's look at number 7. Kind of the same way, or same thing here. I would separate this into the square root of 49 and the square root of -1. 49, you can put in the calculator, you're going to get 7 out. I don't know why my pen's doing that, but we're going to roll with it. And then the square root of -1, as I talked about before, turns into I. Okay, if you need to see this broken down, this is 7 squared, and then I here, and those square and, square root and square cancels and leaves you 7. Okay, so those are when those are perfect squares, like 4 is 2 times 2, 9 is 3 times 3, 49 is 7 times 7. We like those. Those we can evenly put in, or we can put it in the calculator. It comes out with a whole number. Fabulous. Number 8, not so much. 18 is not a perfect square. So there's a number of ways to do this. If you have the TI 30XS Multiview, you can directly put this in your calculator and it will give you the answer. So you got it lucky, okay? However, if you don't have that, I do want to take a minute and break this down for those that need to be able to do that and their calculator won't do it for them. This is also generally the time when students go, let me go get that Multiview calculator. I'll leave that up to you all. But I don't want that to be mandatory for this class, or I would have made it mandatory. Okay, so square root of 18. What I want us to do is break this completely down. So I'm going to show you one way. I'm going to actually show you 2 ways with this. So the first one is to break 18 down using the factor tree. That's probably what you all are most familiar with. If I take 18 and I say what times what gives me 18, some of you may give me 6 and 3. Some of you may be give me 2 and 9. It doesn't matter. Let's do 6 and 3 real quick. Then you're asking yourself if each one of these numbers is prime. Remember, prime numbers are numbers that evenly, or that only divide by the number and 1. Okay, so you can only divide the number and 1 into it. So prime numbers would be 2, it starts with 2, 3, 5, 7, 11, 13, 17, 19. Okay, so you get the idea. 6 would not be it, because it can multiply. I've got 2 numbers that can multiply to give me 6. So here, 6 is not a prime number. We're going to break it down further into 2 times 3. Is 2 prime? Yes. Is 3 prime? Yes. Let's go back up here to this other 3. Is that prime? Yes. So this is really going to be 2 times 3 times 3. So these circled numbers go under that radical. Now, can I rewrite this to be a pair or something squared? Yes, I can. And what I want to do is maybe put that pair in the front. So when I rewrite this, I'm going to write it as the square root of 3 squared. That's going to take care of these 3's. And then the square root of 2. And then we use our rule that the square root and square cancels and just leaves me with 3. And this poor little 2 is going to stay underneath that radical. I kind of say, I know this is silly, but pairs can go out of the house by, together, but singles have to stay in the house by themselves. Kind of depressing, but if it helps you understand this, great. So this answer would be 3 square root of 2. So the only time you can take it out from under the radical is if there's a pair attached with it. The other way to think about this is, can I find a perfect square within 18? So I've got this perfect squares listed here, 2 squared is 4, 3 squared is 9, and so forth. 16, 25, 36, 49. Do any of these numbers divide evenly into 18? Well, 4 doesn't go into 18, but 9 does. So we want to basically find the perfect square, and then what is the other number that you multiply to get 18? 9 times 2 is 18. Then you can separate it into square root of 9 and square root of 2 to write 3 square root of 2. So I don't care which one you do. And then, of course, certainly if you have a calculator, just use that. But that gives you a couple options here. All right, let's look at 60. So I kind of want to use this perfect square. Let's try that on this one. So does 4 go into 60? It does. Let's see if any of these others. Does 9 go into 60? No. Does 16? Does 25? No. So I would rewrite this as 4 times something. Okay, so this would be 4 times 15. I don't really need to break that down more. Now, I want to show you, if you did the factor tree, this would really be 2 times 2 times 3 times 5. Okay? And how would I break this down? Well, this pair can make the 2 squared, but these two have to stay in the house because they have no pair. So they're going to re-multiply together to give you that 15. And that's the same thing as what I would have over here. Square root of 4, square root of 15. Square root of 4 is 2. Square root of 15 stays at square root of 15. And that would be the same thing here. Regardless, you get the same answer. All right, let's put the concept of imaginary numbers with the I along with the concept of 8 and 9. We're breaking it down further together in number 10. So looking at number 10, I've got the square root of negative 20. So first I want to separate this into the square root of 20 and the square root of negative 1. Next, I want to simplify the square root of 20 if I can. So I'm looking for perfect squares within 20. So going up to our perfect square list, does 4 divide into 20? It does. So this is going to be 4 times 5 to get 20 and bring down the square root of negative 1. Now we can break it down even further to do square root of 4, square root of 5, and square root of negative 1. And now we can take the square root if we can, and leave the square root if we can't. So we can take the square root of 4 to get 2. The square root of 5 has to stay. And the square root of negative 1, going back up here to our rule, is I. Okay, so a couple notes on this when you put it in the computer. This I cannot be under the radical. So for example, if you extended that line out, it would mark it wrong. It has to be, radical has to end, arrow out, and then type the I. You can also write this as 2i squared root of 5. And I'm totally fine with that too. You choose. But if you're going to write it the first way, make sure your I is not under the radical. Sometimes I'll get messages, and that will be the reason why it's missed. All right, let's do another one with number 11. So again, I'm breaking this down and taking that negative sign out. So square root of 50 and square root of negative 1. Looking at our list of perfect squares, does 4 go into 50? No. Does 9 go into 50? No. Does 16 go into 50? No. Does 25 go into 50? Yes. So I'm going to separate this into 25, and we could go ahead and separate it right here. 25 and 2. So 25 times 2 gives me 50, and bring down the negative 1. Now we can simplify what we can. So square root of 25 is 5. Square root of 2 is going to say square root of 2, and the square root of negative 1 is I. Or we can write it as 5i square root of 2. Honestly, this is what I prefer, but it really doesn't matter. Mathematically, these two things are the same. All right, now why did I go through all of this? Because now we're going to solve, and we're going to need to be able to simplify radicals. And just for foresight, in the future, we're going to be doing quadratic formula. Many of you remember that. It has a square root in there, and we're going to be simplifying there as well. So all of these rules will still apply now, but also later. Moving on, let's actually see that application of simplifying radicals here with the square root property. We're going to start with a problem that has an x squared in it. So our first goal is to isolate or get the x squared by itself. And we do that, I'm showing you the example first before we work it. We do that by moving the 25 over, and we get our x squared by itself. Now, just like I was telling you earlier, if I've got the square root of 3 squared, that 2 and that 2 cancels each other out to give me 3. That's what I'm trying to find and figure out here. So if I've got x squared, how do I get rid of that square? I take the square root of it, and then that 2 and that 2 will cancel and just give me x. That said, if you do that to one side, you've got to do it to the other, just like we do with any of our linear equations or any equations. So this might give us x, but on the right-hand side, I'm going to take the square root as well. But there's one special thing we have to do with this problem, and that is putting the plus minus in the front there. So it's almost like our absolute value with the plus minus. Very similar, just where we put it is different, or when we put it is different. And then we simplify this. The square root of negative 25 is 5i, and that plus minus gives us our 2 answers. So starting out with an x squared means I'm getting 2 answers that are the same, just different signs. Now that I've talked through that, let's actually work through one. Okay, number 12, x squared plus 64 equals 0. Our first step is to get that x squared by itself. So we're going to move that 64 over by subtracting. That's going to give us x squared equals negative 64. And now I need to get rid of that square. So I'm going to do the square root of x squared. And if I do that square root on this side, I've got to do it on the right-hand side, square root of negative 64. And again, I've got to add a plus minus in there, and that is the rule, and I'll explain why here in just a second. Okay, so this would be x, because that square and square cancels, equals plus or minus, and the square root of negative 64 is the square root of 64, and the square root of negative 1. So this is going to be plus or minus the square root of 64 is 8. The square root of negative 1 is I. And I'm going to write this as 2 answers just like I did in that example. So this would be 8i and negative 8i. Order does not matter. So if you want to write the negative first and then the positive, totally fine with me. Also, no parentheses on this because, again, it is not an ordered pair. It's just a list of answers. So we're getting 2 answers out. So I want to take just a second and explain why the plus minus it has to be put on there. Let me give you a very simple example. Let's say we've got x squared equals 25. What numbers can I put for x to give me 25? That is actually, this is where it kind of is similar to the absolute value a little bit. Because if I choose 5 to put in there, 5 squared gives me 25. But if I choose negative 5 to put in there, negative 5 squared, again, is negative 5 times negative 5, which is 25 also. So I've got 2 different numbers that could be my result. And again, the signs are just different. So same number, different signs. And that's why we end up having to put the plus minus on there. So a little insight into that. Okay. On 13, we're going to divide by 3. X squared equals 8. So that was getting our x squared by itself. Now we're going to take the square root of both sides. We were doing the square root of x squared equals plus minus the square root of 8. Okay, and that square root and square cancels and leaves me with x. Plus or minus, we need to break down the square root of 8. So what perfect square goes into 8? 4. So this would be the square root of 4 and 2. So 4 times 2 is 8. And let's break that down a little bit more. That's plus or minus the square root of 4 is 2. The square root of 2 stays as the radical square root of 2. So our answers here would be 2 square root of 2 and negative 2 square root of 2. All right, and then on 14, we kind of get all the steps thrown in there together. So again, the first step is solving for that x squared, just trying to get that x squared by itself. So we're going to move the 32 over by subtracting. That is 2x squared equals negative 80. And before I take that square root, I need to divide by that 2 in front. So that's going to be x squared equals negative 40. And I've been kind of writing this next step as a separate step, but you can absolutely just do it right here and take the square root plus minus the square root all in that same problem as long as you leave yourself a little more room right there. All right, next up, this is going to equal x because that square root and square is going to cancel. Plus or minus, how do we break down the square root of negative 40? So again, this is square root of 40, and then the square root of negative 1. Plus or minus, how do I break down 40? So what is the perfect square that goes in there? Probably 4. So let's take out 4. And if I do 40 divided by 4, I get 10. And I know it feels like 10 should be able to be broken down more, but again, there's no pair. There's no perfect square in there. It's 2 and 5. Those are not the same. Okay, and then bring down the square root of negative 1. So I get plus or minus, the square root of 4 is 2. Square root of 10 stays. Square root of negative 1 is I. And now I want to write my two answers. And again, I kind of like the I in the front with the 2. So I'm going to write this as 2I square root of 10 and negative 2I square root of 10. So there's a lot going on in that problem. But again, just remember that you've got two identical answers with different signs. So that was using what's called the square root property. Obviously, in the problem, you're taking the square root of both sides to get rid of the square. I do want to make a quick mention that if you go back and look at your absolute value problems, you're putting that plus or minus really early in the problem. So you're isolating that absolute value, then you're putting the plus minus and solving. Here, the difference is you are kind of doing all the solving, then you're putting the plus minus and simplifying. So you cannot put that plus minus until you get down to just x squared equals on this one. Whereas in the absolute value, you're putting it really early and you end up with two totally different answers. Here, same answer, different signs. So the reason I'm kind of harping on this is because I see a lot of students mix those two up. And just remember both the absolute value and the square root property, or quadratic, starts out with an x squared, is going to give you two answers. All right, let's do the opposite of what we just did. So in order to get rid of the square, we took the square root. Now we're going to be looking at radical equations where we have the square root and we need to get rid of that. So here, in order to get rid of the square root, you need to solve for the square root first, or get their square root by itself first. Here, I've done that in 15. It's already done for us. How do we get off that radical, or that square root of 2x minus 19? We're going to do the opposite operation. So the opposite of doing a square root is raising it to the second power. And whatever you do to one side, you've got to do to the other. I like to put parentheses there. Now, what does that do on the left-hand side here? Well, again, remember, there's a little 2 there. So that's 2 with the square root, and that 2 square cancels. And you're just left with what's underneath, 2x minus 19, equals 3 squared is 9. So make sure to actually take the square there. Now you're left with the linear equation. So we just get one answer out of this. We're going to add 19 to both sides. That's going to give us 2x equals 28, divide by 2, and x equals 14. Also, these are pretty easy to just check. So if you put in 14 here, I would get 2 times 14 minus 19, which is 28 minus 19, which is 9, and then I have the square root there. Does that equal 3? Yes. Okay, I'm not saying you have to check it, but it might be good because this is an easy problem to check. All right, let's look at 16. 16, I need to get that radical by itself first. So that means I need to put plus 4 on both sides before I square anything. That's going to give us the square root of x plus 3 equals 2 plus 4 is 6. Now, how do I get rid of the square root? This is where I'm squaring both sides. So this is going to be x plus 3 equals 6 squared is 36. And then I can subtract 3 from both sides and get 33. And again, if I plug it in here, 33 plus 3 is 36. The square root of 36 is 6. 6 minus 4 does give me that 2. So that's a great way to check. Now, I want to make a quick note here. I see a lot of students work this problem incorrectly. You do need to put a star by this. You're going to see this. You're going to see this on test 1. I see a lot of students put these two numbers together before they do anything. You cannot do that. anything that's under that radical, it is like a wall, like a barrier that nothing can cross that. Only something special, like squaring it, can take off that radical. So you cannot put 3 and -4 together. The other thing that I see is people putting squares on each thing. If you put more than 2 squares, then you've done the problem wrong. Okay, this is not equivalent to what I have done here in this problem. Okay, you have to isolate the radical first, then you can square both sides. So that does not work either. Don't do that. Okay, so just that was a quick note on those. Let's look at number 17. We want to get that radical by itself. We're going to move the 3 over. This is the square root of x plus 7 equals -3. Now we've got our radical by itself. We're going to square both sides. That gives us x plus 7 equals 9. And subtract 7, and x equals 2. When I do this in my in-person class, I'm like, okay, that's not the answer. And then they're like, wait, what? Because we just did all that work, and why isn't it the answer? Well, one way you can see that is by checking it. That's kind of why I noted it up there. If I check this, 2 plus 7 plus 3, this is supposed to equal 0. That's going to be square root of 9 plus 3 equals 0. 3 plus 3 equals 0. No, no. 6 does not equal 0. So then I asked, what part of this problem was different than the other two? Why could this be something that doesn't work out? And the most important thing for you to note in this problem is that when we move this 3 over, that made that number negative. And in a similar way that an absolute value can never generate a negative, a square root cannot either. So you are never going to be able to take the square root of a number and get a negative number out. One thing to think about is if I have the square root of a negative number, that comes out I. That doesn't come out negative. Okay, so this can never happen, which means this is a no solution or D&E problem. Okay, D&E in the computer, but if you write no solution on your paper, that's fine. Why did that happen again? Because wherever the square root was equal to a negative, and that was bad. Can't do that. All right. That is all for the equations that we're solving in this unit. Now we're going to use factoring. And I know this is a huge word, and we're going to really get more in depth into this as we move on into future units, units 4, 5, 6, and we're going to actually continue to use factoring throughout the rest of the course. So let's look at factoring, and actually let's start with something we know. So let's not start with factoring to begin with. Let's look at number 18. 18 is distributive property. And this is a good example to start with so that we can understand the process for factoring and what we're doing. So distributive property here, we're doing 2x times 3x. So multiplying 2 times 3 gives me 6. And x times x is x squared. One rule about the x's is that the exponents are both 1. And our rule for multiplying variables is to add the exponents. So that gives us that 2. Minus 2x times 1 is just 2x. Okay, so what we just did was distributive property means we multiplied. All right, so hold that thought for a minute. Let's come over here to 19. 19 can be worked a variety of different ways. If you want to do FOIL method, FOIL, that's fine. If you want to do box method or area method, I'm fine with that. But I do want to show you a specific method today because it helps us with what we're going to do here in a little bit. And that is double distribution. So we're going to use double distribution on this. What does that mean? Well, our first setup is to take that 4x and multiply by the second parentheses. Then we're going to take the second term in that first group, plus 9, and multiply by that second parentheses, again, x minus 7. Okay, so I duplicated that x minus 7 2 times. Now we've got two distributive property problems that we can do. So 4x times x is 4x squared, and 4x times -7 is -28x, plus 9 times x is 9x, and 9 times -7 is -63. And in this case, we are used to adding like terms right here. So let's go ahead and do that. That's 4x squared minus 19x minus 63. And that was FOIL method. So factoring, let's talk about that. Factoring can look like we start with this answer and we get to this result. We start with, I said that wrong, we start with this problem. We start with this problem and we get to our end result. Notice that our quote unquote end result are parentheses for both. So in 18, the original problem was parentheses. That's the answer we would be getting. On 19, original problem had parentheses. That would be the answer we're trying to go for. Okay. Now we're going to take this in pieces so that we build up to it. So we want to do what's called the greatest common factor and find that and factor it out for 20 and 21. Let's talk about the GCF, or the greatest common factor. There are three parts. The first part is the sign. The second part is the number. The third part is the variable. The sign is always the sign of the first term. So if your first term here is positive, your GCF is positive. If the first term is negative, your GCF is negative. The number is going to be either the smallest or smaller. I'll explain that in a minute. And the variable, it has to be in both. And then it is the smallest exponent. Okay, so I kind of just jotted some things down there, but in practice, let's work through this. So our first step is identifying our greatest common factor, our GCF, in number 20. So there are three parts. The first one is the sign. We're looking to the first term to determine the sign. So the sign of the first term is positive. Our GCF is positive. You don't have to always write it, but for this time, I'm just doing it for effect. Number two, the number. We are looking for the smallest number or smaller. So looking at these two numbers, we've got 4 and 18. Your question that you're asking yourself is, does 4 evenly divide into 18? Well, I think we can all say no to that. So if it doesn't, break 4 down into what times what gives you 4. So break it down into its factors. That gives us 2. So does 2 go into 18? Yes. So 2 goes into 4, 2 goes into 18. So 2 is going to be our GCF here, our number part of our GCF. All right. Step 3, variables. There has to be an X in both terms. So be in both means, do I have an X in the first and the second term? And we can see in that second term there, we do not have an X. So if we do not have an X in both, then X is not part of the GCF. So our GCF in this problem is just 2. So we're going to put our GCF out front. And again, we want it to kind of be in this format with a number out front and then a set of parentheses. Now, this next step is a little bit longer. I'm doing this so that those of you that need the longer, more detailed version have it. But if you can do this step in your head, I'm fine with that as well. So our next step would be bringing down 4x minus 18. And we're going to divide both of these by the GCF. So I'm bringing down the problem and dividing by whatever number I put in front. And our last step is to simplify. So we're going to bring down the 2. And now let's do the simplification. 4 divided by 2 is 2. Bring down the x. Minus 18 divided by 2 is 9. And close off that parentheses. You can always check it by doing distributive property. 2 times 2x is 4x. 2 times negative 9 is negative 18. Okay, so that was factoring out the GCF, and that would be the answer. I want to amend or change the problem 21 real quick to make this be a negative 6x squared right there. So that allows us to practice our rules. So looking at this, we first need to identify the GCF, sign, number, variable. So our sign is the sign of the first term. In this case, it's negative. Number, it is the smallest number or smaller. So our smallest number between 6 and 3 is 3. Does 3 go into 6? Yes. So 3 ends up being our GCF number part. And variable. First, it has to be in both. So is there an X in both terms? Yes. So now, how do I decide what X do I take out? Well, it is the smallest exponent. So this is X squared. This is X to the first. So that X to the first is what comes out. At that point, you could just not have to write the 1 and just write the x there. Now that you've identified your GCF, we're dividing. So remember, dividing, up here we multiplied, the opposite is divide. That's why we're doing that, okay? So here, we're going to write our problem, negative 6x squared minus 3x, and we're dividing both terms by whatever you put out front. So this is going to be divide by 3x, divide by 3x. This gives us negative 3x, and be very careful with the signs here. Negative 6 divided by negative 3 is 2. X squared divided by x is x. Negative 3 divided by negative 3 is positive 1, and you have to write the 1, and our x's cancel. Okay, I'm going to close this out, and that will be our answer. Quick note on this. I see a lot of students do 3x minus 3x, or negative 3x divided by negative 3x. Oh, all that cancels. And they don't even write anything there. So just remember, if everything cancels, the answer is 1. Okay, you could also just look at the numbers. 3 divided by 3 is 1. So make sure if you've got 2 terms in the problem, you've got to have 2 terms inside that parentheses in the answer. All right? Okay, so that is factoring out the greatest common factor. Let's take that a step further. So looking at 22, we now have 4 terms, and we're going to factor this by grouping. And again, grouping is typically when you have 4 terms. Now, the first step to grouping is to group. So we're going to group the first 2 terms together. And we're going to put a little plus sign there because mathematically we need to make this correct, and group the second 2 terms together. Obviously, if the plus wasn't there, it would look like multiplication, and that is not what we're doing. Now, this turned this into 2 smaller problems. I've got 2 terms at the beginning and 2 terms at the end, and I want to do the GCF for both. So I'm going to factor out the GCF for both groups. So in this first group, let's talk about the GCF. The sign of the first term is positive, so that's just going to stay positive. The numbers, I've got 4 and 8. The smallest number is 4. Does 4 go into 8? Yes. So 4 is a part of our GCF. The variables is there a variable in both? Yes. So now we're looking for the smallest exponent, and that is just going to be x to the first here, but don't have to write the 1. So 4x is going to be our GCF here. And just like we did before, we're going to bring down that part of the problem. So 4x squared plus 8x. And whatever I put in front is what I divide by. Let's look at our second group here. The sign of the first term is negative, so our GCF for that group will be negative. Looking at our numbers, 5 and 10, 5 is the smallest. Does 5 go into 10? Yes. So 5 is going to be our GCF. Variables, is there a variable in both? No. So there is no GCF variable here. Okay, so negative 5 is going to be our GCF. We're going to bring down the problem, negative 5x minus 10, and divide by that negative 5. Next step is to simplify. So bring down that 4x, and let's look at what we have. So 4 divided by 4 is going to cancel. X squared divided by x is just x, plus 8 divided by 4 is 2, and our x is canceled there. Bring down the minus 5. Negative 5 and negative 5 cancels and leaves me with x. Negative 10 divided by negative 5 is positive 2 or plus 2. And right here is where I really love grouping. Like, I didn't get to see that until college, and I was like amazed. And I always am, because I think it's just really cool how this works out. You may notice there's something in common here, and that is this x plus 2 that's in both terms. So at this point, we can actually go straight to the answer. We're going to have 2 sets of parentheses. In the first parentheses, we're writing our GCFs. So that 4x minus 5 goes in the first set. And then our x plus 2's that are in common, we're not going to write those twice. I'll explain in just a second. But that we're just writing one time as our second factor. So this is the completely factored form, 4x minus 5 times x plus 2. I also want to mention that you could reverse these. So you could write x plus 2 and then 4x minus 5, and that would be totally fine also. One explanation to that is like 2 times 3 is the same as 3 times 2. Okay, so order doesn't matter when you multiply as long as what's inside is the same. So that would be our answer. I want to take a minute and explain why this works out the way it does. So just keep in mind that these two parentheses are the same. Let me go all the way back up here to number 19. Notice that these two parentheses were the same. So how did I get this step? I took the first term here and I put the second term there. Okay, so the stuff in front came from the first parentheses, and the stuff inside the parentheses came from the second parentheses. So I don't know if you can see it going backwards like this, but that's why it looks like that. Okay, so our parentheses should be the same because that is how it works backwards. Okay. All right, so that was grouping. Let's do that again. So looking at 23, we've got x squared minus x minus 5x plus 5. All right, so our first step to grouping is to group. So we're going to group the first two and say plus the second two. Then we're taking out the GCF in each group. So looking in our first group, we've got sign of the first term is positive. Numbers, I really don't have numbers here. I've got ones. So it's really just going to be 1 and you don't have to write that. Variables, so I've got variables in both. So just X is going to be part of our GCF. So really just in this first one, it's going to be X. And a little hint as we're doing grouping, in the first group, X will always come out. Okay, so X will always be part of your GCF in the first group as we continue. That said, let's write our problem out there, x squared minus x, and we're going to divide by x for both. Let's look at our second group. So this one's a little trickier because it's the first time we've had a negative and then a positive. But the sign does not care about anything but the first sign, the first term. So the first term is negative, therefore our GCF is negative. Looking at our numbers, 5 and 5, they're both the same. I think this is probably pretty easy, but 5 goes into 5, so 5 is our GCF. And if we look at our variables, there's only an x in the first term, not the second, so an x will not be part of the GCF. Now that we have our GCF of -5, let's divide. So this is -5x plus 5. Divide by -5 on both. Now let's simplify. So this is x times x squared divided by x is just x, minus, careful here, there's no number to look at, but x divided by x is 1. If you're worried about that, put the ones in front, cancel out your x's, and 1 divided by 1 is 1. Okay, so that does not all go away. You have to put a 1 there. Bring down the -5. -5 and -5 does cancel, and I have x. And then 5 divided by -5 is -1. Okay, so remember that we're writing our two GCFs as one factor, and then our x minus 1s as the other, not writing that twice for the second factor. So x minus 5 goes first, and then x minus 1 second. And again, those two can be reversed if you want. Okay, so we're doing grouping when there's 4 terms. Let's move on to number 24, and that is not 4 terms. You can clearly see this is 3 terms. This is 3 terms. So before we get too much further, I need to talk about the standard form for a quadratic expression. So this is a quadratic expression. It's a quadratic because we have an x squared in the problem. Okay, so ax squared plus bx plus c is the standard form. X squared plus bx plus c. So the a is the number in front of x squared, including the sign. The b is the number in front of x, including the sign. The c is the constant, including the sign. So in this problem, a is 2, b is the 17, and c is 21. Now, this says factor the following using the grouping technique, but I only have 3 terms. What I'm going to do is take these 3 terms and break the middle term apart to make it 4 total terms. In order to do that, I'm going to bring down the 2x squared plus 2 terms. We're not sure what those 2 are yet, but we'll get to that in a minute. Plus 21. So I brought down the first, added 2 blanks, and brought down the last. Somehow I'm going to break this 17x up, and it does matter what numbers you pick here. You cannot just randomly choose. So this is the part of factoring that does get a little tricky. All right, how do we break the 17 up? This is a process. So we're going to go over to the side, and we are now going to calculate A times C. So first times the last number in the problem. A in this problem is 2. C in this problem is 21. And 2 times 21 is 42. All right. What we're asking ourselves is what multiplies to 42 and adds to B. So let's look and see what B is. B is 17. So we want to add to 17. So it multiplies to 42 and adds to 17. This is like a little puzzle. If you don't like puzzles, you probably won't like this. That doesn't mean you can't do it. Just means it may take a little more work. Okay. So what I do, you're not required to do, but I think it's really good to have a list of numbers that multiply to 42 so that we don't skip one, the very one we might need. Okay, so taking 42, we're going to create a list of numbers. What times what gives me 42? So I've got 1 times 42 gives me 42. 2, 42 divided by 2 is 21. Does 3 go into 42? Yes, it's 14. Does 4 go into 42? No. Does 5 go into 42? No. Does 6 go into 42? Yes, 7 times. Does 7 go into 42? Yes, 6 times. So right there, you see that these two things are the same, just swapped. That is where you stop. So now you've created the list of all the potential factors that add or that multiply to 42. Now, take those same two numbers and add them and see if they give you 17. So if I add these, I get 43. That's not going to work. If I add these, I get 23. That's not going to work. If I add these, I get 17. So the numbers that I need are 3 specifically, 3 and 14. So let's go back up here to our problem. Now that we figured out that 3 and 14 will give us 17 when added and multiplied give us 42. Go back up to our problem. We were going to put 3 and 14 here. And remember, we were breaking apart the 17x. So this is going to be 3x and 14x. Okay, now that we've got 4 terms, though, it looks just like our previous 2 problems. So this is where we start doing grouping. So we have that one kind of hard step, and now we're doing grouping. First step of grouping is to group. So we're going to group our first 2 together and our last 2 together. Looking at the GCF in the first group, let's look at our numbers here. Well, first off, let's look at the sign. Sign of the first term is positive, so GCF is positive. Let's look at our numbers. 2 and 3. Does 2 go into 3? No. 2 doesn't break down but into 1 and 2. So really, there's nothing in common here, just 1. And that is okay. If I could not find any other part of the GCF, I might write the 1 right here. However, if I look at the variables here, I have a variable in both, so x is part of the GCF. But like I said, if I did not have that x, I would write the 1. That said, let's bring down 2x squared plus 3x and divide by x for both. In the second group, does 14 go into 21? No. But how does 14 break down? 14 is 2 and 7. Go with the bigger number first. So does 7 go into 21? Yes. So 7 is my GCF. Again, the variable is not going to be included in the GCF because it's not in both. Okay, and then I've got 14x plus 21, and I'm going to divide both of those by 7. So this will be x times 2, x squared over x is x, plus 3, x over x cancels. Plus 7, 14 over 7 is 2, bring down the x, plus 21 over 7 is 3. And right here, we should know if we're on the right track if our parentheses match, and we do have matching parentheses. So now we can go straight to our answer, which again is the GCFs put together, x plus 7, and 2x plus 3 as our other parentheses, our other factor. Okay? And that's our answer. So that's fully factored trinomial. I want to stop real quick and say, you may have learned so many different ways on how to work a problem like this in school. If you have not learned a way, use this way. Okay. If the way you learned, you cannot quite remember it, or you're just not getting it consistently correct, use this way. Okay. If the way you learned, you know, like the back of your hand, and you know how to get it right every single time using your method, then you need to go ask your instructor before any test and say, hey, this is how I'm doing it. Are you okay with this? And explain it to them, make sure that they're good with it, and then you can use that method on the test. But don't use it on the test without getting pre-approval if you're not going to do grouping. Okay? So just a little caveat there, but if you know another way and you can do it consistently, just show your instructor, let them approve it, and you're good to go. All right? Let's do another one. We got really lucky on 24. Everything was positive, but it is not always that way. I don't think we know that. So let's look at 25 and start our process all over again. So step 1 was identifying our A, B, and C. So our A in this problem is 2. Our B in this problem, this is really -1. So we're going to include the sign. Our C in this problem is -28. Next step, we're going to break the problem apart and to make that middle term 2 terms, 4 total. So this would be 2x squared plus blank minus 28. Okay, and now we got to figure out what goes in there. So that's coming over to the side and doing A times C. So A in this problem is 2. C in this problem is -28. And when we multiply that, we get -56. Oh, goodness. I think my pen hit the down arrows. My bad, folks. All right, so what is our question on this? It is what multiplies to -56 and adds to B. B in this problem is -1. All right, so I think let's just start with 56. Ignore the negative sign for now, and we'll talk about that in a second. But let's break 56 down and see what we get. So we've got 1 in 56. We have 2. This is when calculators come in handy. 56 divided by 2 is 28. 56 divided by 3 is nothing. Divided by 4 is 14. Divide by 5 isn't going to work. Divide by 6 isn't going to work. Divide by 7 is not. Oh, wait, yes, it is, of course. 7 and 8, and then we get 8 and 7. So there's where we're stopping. Now, let's talk signs. That was all the combinations for a positive 56, but I need a negative 56. And even more so, I need B to give me a -1. So if I have 2 numbers and they need to multiply to a negative, we talked about this in the very first week of class, 2 numbers multiplied to a negative give you 2 different signs, right? So those 2 numbers have to be different signs. If they're the same sign, remember they're going to multiply to a positive. So one's got to be positive, one's got to be negative. How do I figure out which is which? That is where B comes in. So B is -1. So if I take any 2 numbers and I add them together and they're different signs, remember we're subtracting the numbers and keeping the sign of the bigger. Do you remember that from week 1? So that means that this is the keeping the sign of the bigger. So that means that the sign of B is the sign of the bigger number. Okay, so if I look at my combinations down here, that means all my bigger numbers are on the right-hand side. So that means I would have a -56, a -28, a -14, and a -8 to consider. Now we can add those together. And I'm going to just jump. Y'all probably have already noticed this, but I'm going to jump down here to the answer. 7 plus -8 gives me -1, and 7 times -8 gives me that -56 I'm looking for. I will give you a little hint. If you knew the signs were different, but you got a positive one out, then just swap the 2 signs. Okay, so that's a little hint on that. So we see that our two numbers we're considering are 7 and -8. It does not matter what order you put this in. I'm going to put the 7 first since it's first in the list. So I'm going to do 7x and -8x. Now, we've got 4 terms. Now we're grouping. So we're going to group these first two together and group these last two together. In the first group, 2 and 7 have nothing in common, but I do have an x in common. So we're going to take an x out. And remember, I did say x always comes out of the first group. So writing our problem down and dividing both by x. In our second group, be very careful, okay? First term is negative, so GCF is negative. 8 does not go into 28. 8 breaks down into 2 and 4. The biggest number there is 4. Does 4 go into 28? Yes. So 4 is going to be our GCF, and there's no variable in common because there's no variable in both. Okay, so I bring down that problem, -8x minus 28, and divide both by -4. That's going to be x times 2x plus 7, x is canceled, minus 4 times -8 divided by -4 is 2, bring down the x, and -28 divided by -4 is +7. And just a quick note, I've been saying this already, but if you get these wrong, there's one of two things that are happened. Probably these numbers need to be readjusted, or it's possible that you did not bring that negative out. Okay, but a lot of times it goes down to those numbers that you put in. All right, our last step is to do GCF. And then the numbers in common, or the common parentheses there. And that's our answer. All right, there are a gabillion combinations of a problem like this. This we're going to take in Unit 4 and make it into an equation and actually do some solving. But if I ask you to factor, this is where you stop, is these parentheses. Okay? Let's talk about 26. I'm not going to work all the way through 26 and 27, but the beginning is a little different, so I do want to at least address that. So looking at number 26, first off, these numbers are kind of big. So I want to make my life a little bit easier. And in order to do that, I suggest finding something that is in common with all of these terms, not just the first two, but all of them. And I think you all can probably see that there's a 5 that is in each one of these. So you can actually take the 5 out. So divide each one of these by 5. I'm just going to do it underneath like this. 60 divided by 5 is 12x squared. 25 divided by 5 is 5x. And 10 divided by 5 is 2. So this little 5 hangs out front. And here's what I suggest you do. I want you to come all the way to the bottom, drop that 5 out to the bottom, and then you're going to factor this by grouping, just like we did the previous two. And you're going to get an answer like this. And your final answer you put in the computer will have the 5 out front. I believe on some of your answers or homework problems, I think it gives a little hint. It's like, hint, factor out the GCF first. That's what it's talking about. Is there a GCF in the whole thing that you can factor out first and then consider this separately? Okay, so here you would do, again, add the parentheses, add the blanks. 12 times -2 would give you -24. What multiplies to -24 and adds to -5? And I'll let you do that one. Okay. On 27, it's a very similar thing. It's just not a number that's in common, right? 6 and 9 do have 3 in common, but if you're going to take something out for all 3, it has to be in all 3. So there's no number in common, but if you notice, there is an x in all 3. So we are going to take the x out and divide by x for all 3 of these. That's going to leave me with 8x squared minus 6x minus 9. And just like I did before, bring that x on down. And then you're going to group this. Okay, so using the same thing that we did before, our final answer would have our two parentheses with an x stuck out front. You'll include that x in the answer in the computer. All right, I hope this helped. Stay safe, and thanks so much. Have a good night, everyone.